In this video we're going to be talking about the graphs of magnetic flux, voltage, current and power for alternating current, and also talking about their formulae. One thing we have to recall is the definition of angular frequency, which is 2 pi times the frequency, or 2 pi divided by the period. So if we first bring up the graph of magnetic flux, it's a sine curve which has a formula NBA cosine omega t, where n is the number of turns of the coil, b is the magnetic flux density, a is the area of the coil, and t is time, which is varying. Now, from Faraday's law, induced EMF or AC voltage is the negative rate of change. So the graph looks like this. It's a sine wave instead, and the formula becomes omega NBA sine omega t, where this quantity V0, 0 denoting a peak value, is omega NBA. Next, if we bring up the graph of current against time for AC voltage, you see again it's actually the same type of curve as voltage. It's a sine wave, and that simply comes from the fact that from Ohm's law, V equals IR. I is just the voltage divided by the load, the resistance in the circuit. However, the power versus time graph is slightly different, because power is the product of voltage and current. You have that the power can never become zero, because it's a square. It becomes the square of this function with this function. So you get that the power is omega NBA all squared divided by r times sine squared of omega t. Note that in this graph we go through two maxima during one period, and this can be you can get tripped up on that in exam questions quite easily. So remember, for the power time graph you can never go negative, and we go through two maxima during one period.